Good morning everyone. I am Shibili. I would like to take a seminar on the topic solar cell based on natural dye. A dye sensitized solar cell DSSc is a low cost solar cell belonging to the group of thin film solar cells. It is based on natural dye extracts, provides natural, non-toxic and low cost dye source with high absorbance level of UV visible and near IR. This particular solar cell called DSSc is a low-cost solar cell belonging to the group of thin film solar cell. This type solar cell based on natural dye extract which provide the benefits like non-toxic and low-cost dye source with high absorbance level of UV visible and near IR. UV means ultraviolet and IR infrared. Michael Gratzel and Bruno Regan invented dye-sensitized solar cell, also called Gratzel cells, in 1991. Objectives of the dye-sensitized solar cell are: it is the most cost-effective method than photovoltaic cell to reduce the electricity bill. Its fabrication is simple and very low sunlight is needed for the conversion. Next, preparation. There are two method process: working electrode and counter electrode. First step, working electrode, titanium dioxide coating and firing. Next step, dye adsorbing. Dye adsorbing means dye adding. And next, gel electrolyte printing and ultraviolet curing. And counter electrode, platinum paste coating and firing. And next step, hole drilling. These two forms are going to be combined into the sealing and injection liquid electrolyte and sealing holes and cell test. These two forms are combined. Finally, preparation is completed. Now let's discuss about working schematic representation. This circuit diagram simply working process. First step, dye absorbs light and convert into electrons. Means it absorbs daylight and converts into electrons. Second step, electron moves to the anode through titanium dioxide. Next step, electron passes through external circuit to cathode. This electron reduces triodide to iodide ion in the electrolyte. Iodide ion transfer electron to the dye. The process continuously. Next, result. The completed solar cell or light detector can be taken outside and measured under illumination by sunlight. Means it is possible for completed solar cell or light detector to be taken outside and measured under illumination by sunlight. In order to protect the cell from damage by excessive UV light, a polycarbonate plastic cover should be placed over the cell. Light enters the glass sandwich through the titanium dioxide coated glass slide. Measurements can be taken with a multimeter to determine if the procedure was successful. Maximum current and voltage output can easily be determined by attaching a multimeter directly to the two sides of the cell using wires with alligator clips attached to the end. It means a polycarbonate plastic cover is placed over the cell in order to protect the cell from damage by exclusive ultraviolet light. The Titanium dioxide coated glass slide allows the light to enter the glass sandwich. Measurements can be taken with a multimeter to determine if the product is successful by attaching the multimeter directly to the two sides of the cell using wires with alligator clip attached to their end. And next, the maximum current and voltage output characteristic of solar cell when pomegranate is used as a natural dye. Let's discuss about the result of testing. The output characteristics of solar cell when pomegranate is used as a natural dye. First one, name of organic dye, black grapes. It means black grapes used for organic dye. Next, quantity of dye, 20 ml. Next, light intensity 600 raised to 10 lux. Lux means is a unit used to measure the intensity of light hitting surface. Next, active area of solar cell 4 centimeter square. Next, the first day of observation in a table. Have a look at the table. Here as we can see when the current is 0 and the voltage will be 0.325. Next, current is 0.1 and voltage is 0.320. And the third one, current is 0.2, voltage is 0.316. This follows up to the last part where we can see when the current is 4.9 and then the value of voltage is 0. Next, from the first day of test result, we can represent the graph like this. X-axis represent voltage and Y-axis represent current. From the graph, we can understand that when current is increased, voltage is reducing. This graph we can convert to the table as we can see. The first day result given in the table. Parameters and value. First one, ISSc. Short circuit current 4.9 mA. Second one, VOC. Open circuit voltage value 0.325 volt. Third one, Imax. Maximum current 1.0 mA. Next, Vmax. Maximum voltage 0.286 volt. Next, Pmax. Maximum power 0.286 MW. F.F. Filler factor 117.9 percentage and mu efficiency 8.13 percentage. The total efficiency of the first day is 8.13 percentage. Second day of result, the graph represents shown in the picture. In day 2, voltage is reducing compared to first day. Proportions remain same. Efficiency of day 2 is reduced by half. This graph convert into table as we can see. The table, parameters and value. First one, short circuit current value 3.4 mA. Second one, open circuit voltage 0.3 volt. Next, maximum current 0.6 mA. Fourth one, maximum voltage 0.26 volt. Fifth one, maximum power 0.156 MW. Next, FF, fill factor 15.2 percentage. Fill factor, it means essentially a measure of quality of the solar cell. Next, mu, efficiency 4.45 percentage. And this test is continued till 10 days. The 10th day result given in the table. First one, short circuit current value 2.0 mA. Second one, open circuit voltage 0.25 volt. Third one, maximum current 0.25 mA. Fourth one, maximum voltage 0.6 volt. Maximum power 0.140 MW. Sixth one, F.F, fill factor 28.0 percentage. Mu, efficiency 3.00 percentage. And finally, observation is completed. And next, applications of dye-sensitized solar cell. First one, 200 meter square of dye-sensitized solar cell panels installed in Newcastle, Australia. The first commercial dye-sensitized solar cell module. It means the first commercial dye-sensitized solar cell module. 200 meter square of dye-sensitized solar cell panels installed in Newcastle, Australia. And indoor ornament of dye-sensitized solar cells leaves using Asian Sikiko Ltd. And next application, flexible dye-sensitized solar cell based solar module developed by Dysol. And last application, jacket commercialized by G24i. Next, now we can compare the difference between dye-sensitized solar cell and photovolatile cells. First, DSSc cells. Less cost and flexible. A very low sunlight is needed for the conversion. Next, less efficient and efficiency up to 10%. Fabrication is simple. And next, photovolatile cells. More cost, not flexible. Need a minimum sunlight for the conversion. More efficient, efficiency up to 25%. Fabrication is complex. Next, now let's discuss about the dye-sensitized solar cell advantages and disadvantages. First, advantages. The ability to work at wider angles and in low light. Next, long life, good price or performance ratio. Next, low cost and mechanical robustness. Robustness means mechanically strongest. Ability to operate at lower internal temperature. And next, lowering the electricity bills. And disadvantages. Dye-sensitized solar cell design is the use of the liquid electrolyte. It means electrolyte liquid is used for dye-sensitized solar cell design. Next, which has temperature stability problem. It means stability problem of temperature. Next, costly ruthenium dye or platinum catalyst. Next, the electrolyte solution contains volatile organic components. Conclusion. Good for environment because it is natural. Next, development of this technology is essential. Next, large investment leads to a solution for country's energy crisis. Next, need of government's direct involvement to generalize this idea. Next, large change in economy. Thank you everyone.